Today we're going to start with studying statistics. Our first lesson is about the nature of statistics. This is the first lesson about statistics. In this lesson, we're going to say that uh, as a student of economics and business, you will need basic knowledge and skills of statistics in order to be able to understand, collect, organize, and present data in an informative way. The way to learn these skills is through taking statistics courses. Now, why then students take statistics courses? If you see that statistics is a required course for almost all students in the college programs. If you go through the university catalog, you will see that statistics courses are required for different college programs, such as the school is a required course for the School of Engineering, the School of Art and Sciences, the School of Business, the School of Education, and other colleges. Now, the question is that what are the differences in the statistic courses that are offered in these colleges? The biggest difference is in the examples presented. The course content is basically the same for all these courses that are offered in these schools. For instance, the statistics courses that are offered in the School of Business or Education are taught at a more applied level. However, the statistics courses that are taught in the School of Engineering or the School of Art, School of Arts and Sciences, are usually they usually require calculus and higher level courses in mathematics. Therefore, as you can see, statistics is important for all students studying in the university. Now, the question is that why students, therefore, take statistics courses? As I said at the beginning, first reason for students taking statistics courses is that statistics is a required course. So, therefore, students should take statistics courses in order to use the statistical concepts later on to perform or to conduct research in their fields, because students should be able to know how to collect, organize, summarize, and present data in an informative way. So this is one of the reasons for students taking statistics courses. Now, second reason for students taking statistics courses is that numerical informations are everywhere. If you go through a magazine, a newspaper, or go to any websites, you will see that you are bombarded with numerical information about almost every issue. For instance, you will see numerical information about countries, about business, about politics. Therefore, statistical information or statistics is important because numerical informations are everywhere. Now, second reason is that you must be able to read, of course, and understand the various statistical, of course, studies performed in your field. And to do that, you must have understanding of how to collect, organize, summarize, and present data in an informative way. So statistics or taking statistics courses will allow you to understand the concept, the vocabulary, the other, of course, concepts and other statistical procedures that are, taught in statistics courses. Of course, another reason for taking statistic courses is that you might be later on, as you progress in your field of study, you might be asked to conduct research. And as you know that conducting a research in your own field requires that you have some basic knowledge of statistics. You must be able to how to collect, organize data, how to communicate the results of your project with other people. Therefore, taking statistic courses is important. Also, we can add also a third reason for studying statistics is that the knowledge of statistics will allow you to become a better consumer and citizen. A better consumer because having the knowledge of statistics will make you to, or will allow you to come up with intelligent decisions about the products that are presented in the market. So because you have knowledge of statistics, statistical concepts. Also, having the knowledge of statistics will allow you to become a better citizens because it will allow you to know exactly what's going on in the country in terms of many things. Now, what is meant by statistics? We already discussed the reasons for professional people and students, taking statistics courses. Now, we move to talk about the meaning of statistics. What is meant by statistics? As you can see, statistics is the science of collecting, organizing, summarizing, analyzing, presenting, and drawing conclusions from data. As you can see, the definition suggests that the first step is the collection of data. So once you decide upon the project or the research topic you want to study, the first thing is to collect data. Once data is collected, then you have to organize and summarize the data. You have to organize the data, summarize the data, and of course, analyze that data. And after the collection of data and summarizing data, you must present the data in an informative way. Usually, data can be presented in a frequency distribution or in a graph such as bar graph or histogram or polygon, frequency polygon, and so on and so forth. Once all these things have been presented and you finish from the collection and presenting the data, then after that you have to draw certain conclusions from the process of collecting the data. Now we move to talk about the types of statistics. As you can see that statistics is usually divided into two main types. We have descriptive statistics and inferential statistics. What we mean by descriptive statistics? Usually descriptive statistics is the collection of consists of the collection, organizing, summarizing, and presenting the data in an informative way. So the statistician in descriptive statistics usually tries to describe a situation. Let's give an example to see how we can see whether it is descriptive or not. Consider the following example. This data here consists of XYZ cow farm. We have a farm by the name XYZ. It reports the population of the cow in that farm. It was 10,000 cows in the year 2000, 100,000 cow in the year 2010, and 150,000 in the year 2020. This data, as it is descriptive. Also, it is descriptive if I, calculate the percentage growth rate of cows in the farm from one decade to the next within the data given here. However, it is not descriptive if I want to estimate the population of farms in the year 2030, or if I want to estimate the percentage growth, rate of cows from the year 2020 to the year 2030. Why is that? Because these, statistics, are not, don't take into consideration the past population. However, they are used to estimate future population, and the data, future population, they are not here. So actually, when you exceed the past information, then you are, not talking about descriptive statistics. Yes, we said that we have two types of statistics. We have already discussed descriptive statistics, and we said that descriptive statistics is concerned with summarizing data based upon past events. However, inferential statistics, of course, it is the other type of statistics, which is concerned with computing the likelihood or a chance that something will take place in the future. It consists of theorizing from samples to population, achieving estimation and hypothesis testing, finding relationship among variables, and making predictions. Now we have here certain important terms that we need to explain. Samples to population. A statistician usually, when in this type of science, in inferential statistics, a statistician tries to theorize from or generalize from samples to population. Of course, a sample is a portion of the population that is being studied. Once the sample is properly selected, then most of the time it will consist similar characteristics as the population. Once it is properly selected, then it will be used by the statistician to make inferences about the population. So the population consists of all the subjects that are being studied. Okay, the subjects can be human or otherwise. Achieving estimation and hypothesis testing. Of course, hypothesis testing and estimation also these will be studied as we progress in the course. Hypothesis, of course, testing, of course, is a decision-making. It is a decision-making process for evaluating claims about the population based on information selected from samples. Finding relationships. Also, statisticians tries to find relationship among variables. Okay, use statistics to find relationships, such as the relationship between smoking and health, or the relationship between times of studying and scores on tests. Of course, these are, relationships that are based on statistics among variables, of course, and making predictions. Of course, once the past information and the present information are studied, then the statistician is able to make a prediction based on the information. Now, as we said, the types of variables. Now, we have two types of variables, qualitative variables and quantitative variables. Of course, as far as qualitative variables, as far as the qualitative variable is concerned, we say that when the characteristics of the variable being studied is non-numeric, then it is called a qualitative variable or an attribute. Examples of qualitative variables, such as color of your eyes. The color of your eyes, either blue, green, red, and so on and so forth. This is, of course, is reported non-numerically. Gender, it is either male or female. The country of birth, it is the United States, Lebanon, Syria, Canada, and so on and so forth. The marital status, whether you are single or divorced. Religious affiliation, whether you are Muslim, Christian, or whatever. Okay, so this is about the qualitative variable. Now, the other type of variables is quantitative variables. So when the characteristics being studied is reported numerically, then it is called quantitative variables. Okay, we have two types of quantitative variables. We have discrete variables and we have continuous variables. Those are two types of quantitative variables. Okay, they basically assume numerical values. When you say about discrete variables are result from counting. They can assume certain values, and there are gaps between these values, such as number of bedrooms in your house, 3 bedrooms, 3 rooms, 4 rooms, or 5 rooms. You can say we have 3.5 rooms, so there are gaps. 3 rooms, not 3.5 rooms. So there are gaps between the values. Number of cars owned by your family. There are 3 cars, or 4 cars, or 6 cars. Not there are 3.5 cars, so there are no gaps. Number of students registered in Econ class 200. We have 30 students, we have 40 students, we don't have 30.5 students. We have 30 students, we have 40 students, we have 41 students, and so on and so forth. Now, continuous variables usually results from measurement. Examples of continuous variables, as you can see, yearly rainfall in Lebanon. The yearly rainfall in Lebanon could be, for instance, 50 centimeter. 50 centimeter, of course, a continuous variables can assume any value within a specific or a certain range. For instance, if the recorded value of yearly rainfall in Lebanon is 50 centimeter, this 50 centimeter is between 49.5 and between 50.5 and not including 50.5. The boundaries of 50 centimeter is between 49.5 and 50.5 and not including 50.5. Or the recorded rainfall, if it is 50 centimeter, then the boundaries is from 49.5 up to 50.5 and not including 50.5. Same thing, weight of your younger brother. It results from measurement. His weight could be, for instance, 45, or could be, for instance, 55 kilogram. 55 kilogram, this is the recorded value. Could be between 55 kilogram, could be between 49.5 and 55.5. Okay? Distance traveled to school. If the distance is, for instance, 300 meters, 300 meters could be between 299.5 and 300.5 meters. So, as you can see here, these examples result from measurements, and that's why, of course, they belong to the continuous variables. They can assume any value within a certain range. Okay, notice now, in this chapter, we still need to talk about, level of measurements. Data can be classified according to the level of measurement. Of course, the level of measurement of data dictates the calculations that can be done to summarize and represent the data. Now remember, we have four types of level of measurements. Nominal level of measurements, ordinal level of measurements, interval level of measurement, and ratio level of measurement. Now, we have already studied that we have two types of variables, qualitative variables and quantitative variables. And we already said that qualitative variables are attribute variables that cannot be reported numerically. However, quantitative variables are those that are reported numerically and can be discrete or continuous. Now, here, nominal level of measurements and ordinal level of measurements are related to qualitative data. They are related to qualitative data. However, interval level of measurements and ratio level of measurements are related to quantitative data. That is, data that can be reported numerically. Great. Now, let's talk about each level of measurements. First, nominal level of measurements. The properties of the nominal level of measurements is that there is no natural order or ranking that can be placed on the data. Here, when we talk about nominal level of measurement, we don't expect any kind of order or ranking of the data. Okay? Example, color of the eye. The color of the eye, green, brown, red, pink, whatever. Okay? So we could report the green first, or red first, or blue first. Okay? Or any of the other colors first. It doesn't matter. It does not matter. So order is not that important here. You could say the color is green, red, or blue, green, red. It doesn't matter. Whether you put the green first or blue first, it doesn't make any difference. Gender is another example. The gender is another example. You could say, male or female or male. It does not matter. We move to the second level of measurement, ordinal level of measurement. Here, the data can be ranked or ordered. So order is important. Here, in those level of data, which are related to qualitative data, order is important. So example, ratings of a product made by XYZ firm. The rating is superior, good, average, poor, or inferior. So the order is important. The ranking is important here. As you see here, the superior, yes, indeed, is better than good. Good is better than average, and so on. Therefore, order is important. Order here is important. Great. Now, we move to interval level of measurements. Now, interval level of measurement, as you can see, 0 is just a point on the scale. It does not represent the absence of the condition. A good example of this is the temperature. For instance, 0 degrees Fahrenheit does not represent the absence of heat. 0 degrees Fahrenheit is about minus 18 degrees on the Celsius scale. So as I said here, 0 is just a point on the scale. It does not represent the absence of the condition. Interval level includes all the characteristics of the ordinal level, but in addition, the difference between values is of a constant size. An example is temperature. For instance, the difference between 13 degrees Fahrenheit and 15 degrees, the difference between 15 degrees Fahrenheit and 13 is, 2 degrees. The difference between 25 degrees Fahrenheit and 23 degrees Fahrenheit is 2 degrees. Okay, so as you can see, the difference between is of a constant size. Now we move to ratio level of measurements. The properties, it has all the characteristics of the interval level, but in addition, the 0 point is meaningful and the ratio between two numbers is meaningful. For instance, wages, okay, units of production, weight, distance between two places. Money is a good example. Weight, for instance, you could see here, his weight is 0, makes sense. Okay, his weight is 0, makes sense. He has 0 money in his account, makes sense. Okay, distance between two places, the distance is 0. They are very close to each other. So 0, the 0 point is meaningful. Okay. Now, so when we say that he has no money in his account, that is 0 money in his account, it makes sense. It's meaningful. But it's not meaningful when we talk about interval level of measurement. Okay, interval level of measurement. 0 doesn't mean the absence of a scale or the absence of the condition with respect to the interval level of measurements. However, 0 here is meaningful when we talk about ratio level of measurement. For instance, money is a good example. If you have $0, then you have no money. Weight is another example, talking about ratio. If your weight is 100 kilogram and somebody else weight is 50 kilogram, then we could talk about ratio. The ratio is 2 to 1. 100 kilogram and the other one is 50 kilogram. So we could talk about the ratio. 100 over 52. So the ratio is 2 to 1. So here, weight is another example of showing, a ratio level of measurements. And of course, these are, the examples of ratio level of measurements. Okay, now we move to solving some problems in this lesson, which is the lesson, what is statistics? Problem number 1, tell whether each variable is a quantitative variable or a qualitative variable. We already discussed the meaning of qualitative and quantitative, of course. Quantitative variable result from, of course, can be reported numerically. And qualitative variables, of course, is about, it's not reported numerically. Okay. Now, a number of employees of a production firm. Of course, number of employees could be 5, could be 6, could be 10. So this is basically is a quantitative variable because it's reported numerically. Okay. Distance students drives to school every day. A distance could be 1 mile, could be 1.5 miles, could be 1.6 miles. It's a continuous, but it is a quantitative variable. It's a quantitative variable because it's reported numerically. Your field of study at LIU. You study what? In the School of Business. What's your field of study in the School of Business? It's accounting, business, management, information system, economics. So basically it is what? It is qualitative because it is about attribute. Okay? It's not reported numerically, so it is a qualitative variable. Your score on an economics exam, your score is what? It could be 20 out of 100, could be 50 out of 100, could be 70 or 80 or 90 out of 100. So the score is reported numerically, therefore it is a quantitative variable. Ranking of athletes in a competition. Ranking. First, second, third, fourth. So these are qualitative. Okay? Qualitative. Or superior, good, average, whatever. Okay? So these are qualitative because they give an attribute to the variable. The color of drafts provided during finals. Of course, the color could be red, could be blue, could be green. Therefore, these are related to qualitative variables because they talk about attribute. The number of hours spent during studying for econ exam. The number of hours spent studying for econ exam. How many hours do you spend to study for the econ exam? I spent 6 hours. 6 is reported numerically. Therefore, it is related to quantitative variable. So it is a quantitative variable. The salary you expect. The salary you expect to get when you start your job. Of course, your expectation of the salary, could be $500 per month, $1,000 per month, $1,500 a month. So these are reported numerically. Therefore, they are related to a quantitative variable. The list of students' names registered in your class. List. Okay? The roll of a student's name. You get Muhammad, Ibrahim, Tony, Adam. So the list of the, of course, names of a student registered in your class. That list is basically, of course, it is quantitative, related to qualitative variables. Okay? Qualitative variables. Now, we move to problem 2. Problem 2, specify the level of measurement for each statement below. Remember, we have 4 levels of measurements. 4 levels of measurements, namely nominal, ordinal, interval, and ratio. And we said already that nominal and ordinal are related to qualitative variables, while, of course, interval and ratio are related to quantitative variables. Let's look at the questions statement. Classification of people by their educational level. What education level? Could be what? Junior, freshman, sophomore, junior, senior. So these classification of people by their education level, as you can see, these are what? Are not part of the quantitative. They are part of qualitative. So if these are can be ranked. First, freshman, sophomore is higher than freshman, junior is higher than sophomore, and senior is higher than junior. Senior higher than junior, junior higher than sophomore, and sophomore higher than freshman. Therefore, here we're talking about ordinal type of level of measurements. Number of hours spent by children watching TV every week. Number of hours, of course, here belongs to a ratio level. Why? Because as you can see, 0 is a meaningful, and the ratio between 2 numbers is meaningful. For instance, number of hours spent by children watching TV every week, let's say 10 hours. And we state another statement. Number of hours spent by children watching TV, every week in another town. Number of hours spent by children watching TV every week in town A. Let's say 10 hours. Number of hours spent by children watching TV every week in town 2, 20 hours. Can we talk about ratio? Yes, the ratio is meaningful. So the numbers, the ratio of hours spent by children in watching TV in town, 2 is 20, and the number of hours spent by children watching TV every week in town 1 is 10. So we could talk about the ratio, 20 to 10 to 1. So there is the ratio 2 to 1. So this is, we're talking about ratio level of measurements, okay? Ratio level of measurement, because we could say that the number of hours spent by children watching TV every week is 0. And 0 is a meaningful in when you talk about ratio level of measurements. Measuring yearly rainfall in Sidon. Well, measuring yearly rainfall in Sidon. Well, here we're talking about ratio because, when we measure the rainfall in Sidon, we get 0. We get 0 level of rainfall. Or we get, some number could be 10 centimeter or 20 centimeter. Okay? Or we could talk about ratio. For instance, we could say the yearly rainfall in Saida last year was 15 centimeter. And the yearly rainfall in Saida this year is 30 centimeter. So we could talk about ratio. 30 over 15, 2. The ratio is 2 to 1. So it is a ratio level of measurements. Sizes of a dress, example, small, medium, large. This is, is kind of what? It is ranking, okay, rating. Small, medium, large. Medium is bigger than small, large is bigger than medium. So it is what? Here we're talking about ordinal type of ordinal level of measurements. Why? Because rating, ranking. Different brands of television in the market. Different brands could be, different brands. There are different brands, of course, of television in the market. It could be nominal. Brand X, brand Y, could be X first or could be Y first. So it doesn't matter which brand is first. Therefore, it is nominal. The senator's name is Sam Wilson. Sam Wilson, this is his name, a description of his name. So it is nominal. It is nominal. It's not Wilson Sam, this is like this. The company CEO is 60 years old. Of course, it is a ratio. The company CEO is 60 years old, and the company CEO was 40 years old last year. Somebody else. So we could talk about a ratio between 60 and 40. Okay, so this is a ratio type of level of measurement. The annual income of a senior employee is $60,000. Still, it is a ratio. It could be his annual income is 0, nothing. 0 is meaningful. The ratio of two numbers is also meaningful. The annual income of a senior employee is $60,000. The annual income of another senior employee is $120,000. So we could talk about a ratio between $120,000 and $60,000, and the ratio is 2 to 1. So it is a ratio. Now we move to, we're still here, HI, room temperature in CEO private office. Room temperature, of course, this one is interval. Temperature is an example of interval. Okay? 0 temperature, it does not mean the absence of heat. So it is an interval type of level of measurements. A driver is ranked 7th in a car race. So this is what is an ordinal. This is an ordinal level of measurement. It's ranking we're talking about. When we talk about rating or ranking, we're talking about ordinal level of measurements. We move to problem 3. Tell me whether each statement corresponds to a sample or to a population. Remember, a sample is a portion of the population. Population consists of all subjects, okay, under study. Respondents to a magazine survey. When we're talking about respondents to a survey, we're talking about a sample, because it could be 20 people responding to a magazine survey, it could be 100 students, or it could be 100 individuals in the city, but the city consists of thousands, and only 50 or 100 or 500 person responded in that survey. Therefore, they consist of the sample. Average height of people randomly selected from a database. Average height of the people randomly selected. So therefore, we're talking about a sample, because we selected, some sample of it. All Lebanese university students in 2005 academic year. All Lebanese university students in 2015 academic year. Here we're talking about all Lebanese university students. All students in the Lebanese university in 2015. That is population. Talking about the Lebanese university students. We're talking about here the population of students in that university. It could be 500 students, it could be 5,000 students. So they consist of the whole subject in their study, which we call them the population. Number of houses sold in Lebanon during 2016 or 2016. Number of houses sold in Lebanon. So we're talking about number of houses sold in Lebanon. We're talking all Lebanon. So we're talking about a population, because we're talking about all houses sold in 2015 and 2016. Smokers in the country of Lebanon. Here we're talking about all smokers in Lebanon. So we're talking about population. Okay? So when we're talking about the whole people under study, then we are talking about the population. However, when we talk about a portion of that, population, then we are talking about a sample. Okay, now we move to problem 4. Problem 4, for each of the following statements, identify the variable, indicate the type and level of measurements, then classify the quantitative variable as continuous or discrete. So we have many types of the questions that we need to identify. We need to identify the variable, the kind of variable do we have, whether it's qualitative or quantitative, and if it's quantitative, whether it's discrete or continuous, and the level of measurements. Okay, now the first statement, the color of automobiles involved in severe accidents. So the variable here is the color of automobiles. Now, here we're talking about a qualitative variable, because it's not reported numerically. Of course, it talks about color. It talks about an attribute. Therefore, it is qualitative. Now, because it is qualitative, then we don't expect to have neither discrete nor continuous. Now, here we talk level of measurements. Of course, the color of automobiles could be red, blue, green. Could be red could be the first, or green the first, or yellow the first. It does not matter. Therefore, it is nominal. Now, the length of time required for rats to move through a maze. Length of time. Of course, here the length we're talking about, it's reported numerically. Now, the variable is the length of time required for rats to move through a maze. This is the variable, length of time. Now, the type, of course, it is quantitative. Now, what type of quantitative do we have? Of course, it is continuous. Why? Because it talks about a value, a specific value within a certain range. It's a result of measuring. It could be the length of time. It could be 1.2 minutes, or it could be 1.2, 3, 4, 5 minutes. Therefore, it is continuous. Okay? When we talk about continuous, it's a result of measuring. Okay? Rather than, discrete, which is the result of counting. Now, of course, it is length of time required. It's continuous, of course, not discrete. Now, the level of measurements of the length of time required, of course, here we're talking about ratio. length of time could be 0, okay, or could be a ratio. Therefore, it is a ratio because 0 is a meaningful, and the ratio is also meaningful when we talk about ratio level of measurement. 3, the rating given to a pizza in a taste test as poor, good, or excellent. Of course, the rating, the variable is the rating given to a pizza. This is the variable. Now, the type of the variable, of course, the rating given to a pizza, of course, you're talking about either good, poor, or excellent. Therefore, it is qualitative. Now, here, because it's qualitative, therefore, we don't have discrete nor continuous. Of course, the rating, it's what kind of level of measurement? It is, of course, it's ordinal. It is an ordinal because, poor is different than good, and good is different than excellent. Poor is lower than good, and good is lower than excellent. Therefore, there is a rating or ranking. Now, number 4, the number of luxury rooms in a 5-star hotel. Of course, the number of luxury rooms. The variable is the number of luxury rooms. Now, what kind of variable is that? Of course, it is, quantitative. Of course, and quantitative, of course, the number of luxury rooms could be 1, could be 5, could be 10 rooms. Therefore, it is discrete. Because when we're talking about discrete, we're talking about as a result, that comes out from counting. As a result of counting, this is discrete, okay? And discrete, there are gaps between values. You can't have, 1.2 rooms or 2.5 rooms. You have 1 or 2 or 5 or 10. There are gaps between the values. Therefore, we have a discrete variable. Now, of course, what level of measurements do we have? The number of luxury rooms, of course, this is a ratio type of course, level, because we could have 0 rooms, so 0 is meaningful with respect to ratio, or we could have a ratio, okay? Ratio between 2 numbers. So it is, it is a ratio. The last one is the number of students registered in the CFA exam. Now, the variable is the number of students registered, or the number of registered students. This is the variable. Now, the number of students, of course, we're talking about as a result of counting. The number could be 5, could be 6, could be 7. So it is, quantitative. Now, because it's the result of counting, it is discrete, because there are gaps between the values. The number could be 5, could be 10, could be 15. You can't have 5.2 or 10.6. It is the result of counting. Therefore, it is discrete. Now, what about the level of measurements? The number of students registered in the CFA could be 0 students. So, or it could be a ratio. Ratio is meaningful and the 0 is meaningful. Therefore, the level of measurement is ratio. Okay?